This question is the 2011 AP free response question number 5. And we're only going to be looking at a partial here. We're just going to be looking at part C of that free response question. The question asks us to find the particular solution, W equals W of t, to the differential equation listed here. And we're given an initial condition, W at 0 is equal to 1400. To do that, what we want to do is separate our variables. So let me go ahead and rewrite the differential equation real quick for you here. And we want to move everything that has a W to the left and then everything that has a T to the right. So what I'll do here is I'll multiply each side by dt, then the dt's will cancel. And then I have to divide by W minus 100 or multiply by the reciprocal to each side. So we'll multiply that by 1 over W minus 300 to each side. The W minus 300 here will cancel with this one. So on the left-hand side, I'll have 1 over W minus 300 dW is equal to 1 over 25 dt. So everything that has W in it is now on the left, and anything that has T in it is over on the right. You could also multiply each side by 25 as well here. That'd be fine. We're just going to go ahead and take the integral of each side or find the antiderivative. Remember, the left-hand side is the special rule that we need here. We can't use any kind of reverse polynomial rule. And so we need to represent this as the antiderivative being the natural log of the absolute value of W minus 300. Next, on the right-hand side, I need the antiderivative of 1 over 25, which is 1 over 25t, that's our variable. And then, of course, plus some constant c. Looking above, we can use our initial condition now, which is right here, where t is 0 and w is 1400, or w of t is 1400. So I'll substitute 1400 in for my value of w, and then I'll have 1 over 25 times my t value, which is 0, plus c. So 0 times anything is 0. That term will be gone. And I'll be left with c being the natural log of 1100. And you don't need the absolute value bars anymore because 1400 minus 300 is 1100, and that's positive already. So the absolute value of 1100 is 1100. We're going to utilize that now in this equation where I have the natural log of the absolute value of W minus 300 is equal to 1 over 25t, and then I have plus the natural log of 1100. I now need to solve this. That should be a plus sign right here. I do need to now solve this for W. So I'll change this into an exponential. W minus 300 is equal to e to the 1 over 25t plus the natural log of 1100. And I need my absolute value bars there. Can't forget about those. If I'm going to get rid of the absolute value, I need to put the plus or minus on the right-hand side. And I'm going to break up my exponent here in the base into e to the natural log of 1100. That's right here. And then times e, and I'll just represent 1 over 25t as t over 25. That's a multiplication symbol. I can also add 300 to each side. And then e to the natural log of 1100 is just 1100. And then I have e to the t over 25 power. I'm still not finished yet. If I look at my initial condition, at time 0, I need there to be 1400 of whatever w is. So I know that I need to pick the positive sign here. If t is 0, e to the 0 power is 1, and I want 300 plus 1100 to be 1400. So if I'm looking at my initial condition, my choice on the plus or minus sign is definitely the plus sign. There is your particular solution to the given differential equation with the initial condition.